Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections of the points. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a point which is located into the first quadrant, and we know that whenever a point it is located into the first quadrant, so we are going to obtain the point above the horizontal plane and in front of the vertical plane. So here we are required to obtain the front view, top view, left hand side view and the right hand side view projections of a point. So here we have got the horizontal plane, the vertical plane and the profile planes, which are going to divide the space into four quadrants over here. So this is the first quadrant, this is the second quadrant, this is the third quadrant and this is the fourth quadrant. So whenever a point will be located above the horizontal plane and in front of the vertical plane, we are going to obtain the location of a point into the first quadrant. Now here we have got horizontal plane, vertical plane and the profile plane. And we know that the projections which we are going to obtain upon these three mutually perpendicular planes of projection over there, they are going to be available with us into three mutually perpendicular directions over here. In order to obtain the two-dimensional orthographic projections onto a single plane, so we have to carry out the rotation of two of these three planes over here. So we know that whenever we are going to look at the object from the front, so the projection which will be obtained onto the vertical plane will be called front view projections over here. And since we are able to obtain the projections onto the vertical plane directly, so we are not going to carry out rotation of the vertical plane over here. Whereas when we are going to look at the object from the top, so whatever projections we are going to obtain onto the horizontal plane, so this horizontal plane we have to rotate in the clockwise direction. So we can see that onto the front side of the vertical plane, the horizontal plane will be rotated into the clockwise direction, that is below this XY reference line. Whereas behind this vertical plane, so this horizontal plane will be rotated into the clockwise direction in the upward direction over here. Whereas into the front side of the vertical plane, we are going to obtain the downward or the clockwise rotation of this horizontal plane. Similarly, whatever projections we are going to obtain onto the left profile plane or the right profile plane, so these two profile planes, they are perpendicular to both horizontal plane and the vertical plane. So we need to carry out the rotation of the projections which are obtained onto the profile planes in such a way we should be able to obtain all these three projections into a single two-dimensional plane over here. So what we have to do now, we have to carry out the rotation of this profile plane in front of the vertical plane, that is this portion of the profile plane will be rotated in this orientation, that is using this hinge over here. We are going to rotate left profile plane into this orientation. Similarly, this right side profile plane, we are going to rotate using this hinge over here into this orientation. So we can say that the left side profile plane, which happens to exist in front of the vertical plane, it will be rotating towards the left hand side, whereas the right side profile plane, which is available towards the front side of the vertical plane, it will be rotated towards the right hand side orientation over here. Similarly, this portion of the profile plane which lies into first and fourth quadrants, it will be rotated into these two orientations over here. Similarly, this portion of the profile plane will be rotated using this hinge over here. So this portion of the profile plane, it will be rotated into this orientation. Similarly, this portion of the profile plane, it will be rotated into this orientation over here. So this way we have to carry out rotations of horizontal plane as well as profile plane in such a way that the three projections, that is the front view projections, the top view projections and the side view projections, which we are going to obtain, all these three projection views, they should be obtained alongside a single two-dimensional plane over here. Now let us see how these planes of projection, they are going to behave when we are going to open out different planes of projection into the first quadrant. So here we have got horizontal plane, vertical plane, left side profile plane, right side profile plane. So as we have discussed, horizontal plane will be moving downwards, left profile plane will be moving into this orientation, right side profile plane will be moving into this orientation. Now we can see horizontal plane has moved down. So while we are trying to move left side profile plane into this orientation and right side profile plane into this orientation. Now here we have got the front view projections obtained in the first quadrant above the XY reference line. The top view orthographic projections will be obtained by rotation of this horizontal plane in the clockwise direction. So it is obtained below the XY reference line over here. So therefore the top view projections, they have been obtained below the XY reference line, below the front view projections over here. And now we can check as we are looking from the right side. So the projections, they are obtained on the left side profile plane and it is opening on this side. So the right side view of the object will be obtained on left hand side of the front view projections above the XY reference line over here. Similarly, when we are going to look at the object from the left hand side, so projections will be obtained on the right profile plane over here and this will be moving towards the right hand side direction over here. So the left side projections which are obtained on the right profile plane, they will be obtained on the right hand side of the front view projections above the XY reference line over here. So this is the final orientation: front view orthographic projections, top view orthographic projections, right side projections on the left side, and left side projections will be obtained on the right hand side of the front view orthographic projections over here. So let us proceed to evaluate the orthographic projections of a point which is lying 35 millimeter above the horizontal plane and 20 millimeter in front of the vertical plane. So here we have obtained a point A lying at a distance of 35 millimeter above HP and 20 millimeter in front of VP. As the observer is going to look at this point from the front, so we are going to obtain the front view projections of this point A as A dash onto the vertical plane at a distance of 35 millimeter above the horizontal plane over here. When the observer is going to look at this point from the top, so the top view projections of this point A will be obtained onto the horizontal plane at a distance of 20 millimeter from the vertical plane over here. Now let us discuss the relationship between the front view orthographic projections and the top view orthographic projection. So both of these orthographic projections, that is front view A dash and top view projections A, they are lying onto the mutually perpendicular planes. So once we draw these two projector lines over here, so we are able to establish that this is the relationship between front view projections and the top view projection. And once we rotate this horizontal plane in the downward direction, so we will find that A dash and A point, they are going to lie onto the same vertical projector line over here. Now let us obtain the top view projections after this rotation over here. So we are going to take this much radius. So keep the needle of the compass over here. Open compass is equal to the radius 20 millimeter, which happens to be the distance of point A from the vertical plane. So through this point, that is onto the XY line, which is the intersection of the horizontal plane and the vertical plane. So through this point, we are going to take up this radius 20 millimeter, rotate this point A, that is the top view projection, onto the vertical plane over here, that is this horizontal plane has been rotated downwards into the clockwise direction, and this point A will be obtained onto the vertical plane after rotation. So now we can check A dash and A points, they are going to lie alongside the same vertical projector line over here. Now let us obtain the side view projections of this object. So here we have got left profile plane first of all. Now we already know that onto left profile plane we are going to obtain right hand side projections of the solid. Now when the observer is going to look at this object from the right hand side orientation, so observer is located at the right hand side orientation, in between we have the object, finally we will have the plane of projection. So observer looking at this object from the right side will be obtaining the right hand side view projections A double dash of this point onto the left side profile plane at a distance of 35 millimeter above the horizontal plane and 20 millimeter from the vertical plane over here. So this way the right hand side view projections of this point, they have been obtained onto the left side profile plane over here. Similarly, as the observer is going to look at this object from the left hand side orientation, so now we will have the observer, the object, that is the point, and the right side profile plane over here, onto which the left hand side view projections, they will be obtained as A double dash onto the right profile plane, and once again they will be obtained at a distance of 35 millimeter above the horizontal plane and 20 millimeter in front of the vertical plane. And now we know that left profile plane will be rotated like this and right profile plane will be rotated like this. Now we have already checked A dash, A double dash and this A double dash. All of them, they are lying into mutually perpendicular planes, and unless we carry out these rotations of the planes over here, that is horizontal plane, left profile plane and the right profile plane, so we will not be able to obtain all of these orthographic projections into a single 2D plane over here. Now by drawing these three projector lines, we have been able to establish relationship between A dash, A double dash and this A double dash. That is, all of these three projections, they are available at a distance of 35 millimeter above the horizontal plane. Similarly, when we draw these three projector lines over here, we have been able to establish relationship between plan projection and the profile view projections over here. That is, all of these three projections, they are available at a distance of 20 millimeter from the vertical plane. So now, having discussed the 3D spatial representation of these three projections into the 3D spatial view, now let us evaluate the orthographic projections of a point into 2D orientation. So here we have got XY reference line, then corresponding to this left profile plane, we have got X1, Y1 reference line available over here. Similarly, corresponding to this hinge over here, corresponding to the right profile plane, so we have got another vertical X1, Y1 reference line available over here. So this area is the vertical plane which is located over here, onto which front view projections will be obtained. This area, it is the horizontal plane which is available over here, onto which top view will be obtained. This area, it is the left side profile view which has been opened up through this hinge over here into this orientation. So onto this particular space, we are going to obtain the right hand side view projections over here. And finally, this is the area which is corresponding to the right profile plane. So this is obtained through this particular hinge as we open out right profile plane towards this right hand side over here. So onto this particular area, the left side orthographic projections of the point will be obtained over here. Now when the observer is going to look at this object from the front, so we are going to obtain front view projections obtained onto the vertical plane over here. So now the front view orthographic projection, that is point A dash, we have already discussed. It is located at a distance of 35 millimeter above the XY reference line or above the horizontal plane. So we have marked point A dash as front view projections at a distance of 35 millimeter above the horizontal plane or above the XY reference line. Similarly, we have also drawn point A, which is the top view orthographic projections, and we have already discussed they were obtained onto the horizontal plane over here, and A dash and A, they were available onto the mutually perpendicular reference planes over here. So now horizontal plane has been rotated into the clockwise direction. So now A dash and A point, they are available with us onto the same vertical projector line over here, and this distance is equal to 20 millimeter. So now at a distance of 20 millimeter below the XY reference line, we have been able to obtain point A, which happens to be top view orthographic projections of a point obtained onto the horizontal plane over here. Now let us proceed to evaluate the side view projections of this point A. So now we know that as we are going to look at this left side profile view over here, that is when the observer is going to look at this object from the right side orientation, so this projection of the point A will be available onto the left profile plane. That is, the right hand side view projections of this point will be available on the left hand side of this front view projection over here. Now we have to draw a transfer line at an angle of 45 degree with respect to XY reference line or the X1 Y1 reference line. So once we draw a horizontal projector line through the plan projection view onto the transfer line, now through this point we have to take a vertical projector line in the upward direction into the left hand side view profile plane over here, and we know that we are going to obtain this point A double dash, that is the right hand side view projection of this point A at a distance of 35 millimeter above the horizontal plane and 20 millimeter in front of the vertical plane. So we know that we will be able to obtain the right hand side view projection of this point A onto the left profile plane wherever this horizontal projector line drawn through point A dash into the left profile plane, it intersects with this projection line which has been transferred into a vertical projector line into the left profile plane. So this intersection of these two projector lines will provide us with the location of the point A double dash into the left profile plane over here. And why we have just carried out this transfer of this projection from the point A? Because we know that this distance happens to be 20 millimeter from the vertical plane. So as we use this transfer line to transfer this distance of 20 millimeter from the vertical plane, we will be able to ensure that this point A double dash, it happens to lie 20 millimeter from the profile plane over here. So this distance will be this distance of 20 millimeter from the vertical plane that we have been able to obtain into the profile view projection. This distance happens to be 35 millimeter from the horizontal plane, while this distance happens to be 20 millimeter from the vertical plane over here. Now let us obtain the left hand side view projections of this point A onto the right profile plane. So now, in order to obtain the left hand side view projections, what we have to do, once again, we have to draw another transfer line toward the right hand side view projections over here, such that this hinge we are able to obtain over here. Now once we draw a horizontal projector line through point A. Why we have drawn this horizontal projector line? Because we want to transfer this distance of 20 millimeter from the vertical plane. This distance happens to be equal to 20 millimeter. And now once we transfer this horizontal projector line into a vertical projector line using this transfer line, so now we have been able to appropriately transfer this distance of 20 millimeter from the vertical plane into the right profile plane projections over here. And further, we also know that the height at which the point A double dash is going to lie, this is 35 millimeter above the horizontal plane. So now through point A dash, if we draw a horizontal projector line, so wherever this horizontal projector line drawn through point A dash, it is going to intersect with this vertical projector line which we have obtained through this point A. So this intersection point will provide us with the location of point A double dash, which happens to be left hand side view projection of this point A onto the right profile plane. So these projections we have named as left hand side view projections. Why? Because the observer is looking at this object or the point A from the left hand side orientation. So the projections they have been obtained onto the right profile plane. So here we have been able to obtain the front view projections of this point A as A dash above the XY reference line. The top view projections of this point A, they have been obtained below the XY reference line. Then the right hand side view projections of this object A have been obtained on the left hand side of the front view projections above the XY reference line. Similarly, the left hand side view projections of this object, they have been obtained on the right hand side of the front view projections above the XY reference line. So this is all for today. So we are going to continue with further discussion regarding few more illustrative cases of projections of the points in the coming lectures. So thank you very much. Thanks a lot.